Now we're on to section 5 in your review with the proofs. Alright, I'm going to start on the left side, and what I'm going to do first is rewrite the top part in sines and cosines. Secant is 1 over cosine. Tangent is sine over cosine. All of it still over the cosine squared x. So I'll combine the two fractions together because they already have common denominators. One minus sine squared, that is a Pythagorean identity, because the sine squared plus the cosine squared is 1. So 1 minus sine squared would have to be cosine squared. So I have cosine squared x over cosine squared x all over cosine squared x. That means I have 1 over cosine squared x for this first fraction. And remember, I still had this minus 1, which technically carried down with everything. And 1 over the cosine squared x is secant squared x. And secant squared x minus 1 is also a Pythagorean identity. It's manipulating the identity tangent squared plus 1 equals secant squared. So secant squared x minus 1 would have to be tangent squared x, which is what we were going for. 5p. Secant squared x minus 1 equals tangent squared x plus cosine squared x minus 1 over 1 minus cosine squared x. So first I started with getting rid of the 1 minus cosine squared x because that is a Pythagorean identity. One minus cosine squared would have to be sine squared. Then I did with the top of the fraction, I wrote everything in terms of sine and cosine. And then I got common denominators, so this is going to be this last fraction will be cosine squared over cosine squared. So then when I combine them together, I have the sine squared x plus the cosine to the 4th x minus cosine squared x all over cosine squared x all over the sine squared x. Then I got kind of stuck, so I multiplied by the reciprocal. So this fraction on top gets multiplied by 1 over sine squared. So I have sine squared x plus cosine to the 4th x minus cosine squared x over cosine squared times sine squared. And then, since I only have multiplication on the bottom, I broke this fraction up. And I said sine squared x over cosine squared x sine squared x plus cosine to the 4th x over cosine squared x sine squared x. And then I have minus cosine squared x over sine squared x. And then I canceled things, so these sines cancel each other out, and I have 1 over cosine. These two cosines cancel with 2 of the cosines on the top, so I have cosine on squared over sine squared minus, let's see, the cosines cancel, and I have 1 over sine squared. So if I simplify these, I have the secant squared plus the tangent squared, cotangent squared, minus cosecant squared. And cotangent minus cosecant makes me think about a Pythagorean identity. So I know the Pythagorean identity with cotangent and cosecant in it is this. So cotangent minus cosecant, I would have to move the cosecant over here and move the 1 over here. So that's -1. And secant squared x minus 1 is another is what I was going for. All the way at the beginning. So I'm finished. The next proof, 5c, 2 cosecant squared x equals 1 over 1 minus cosine of x plus 1 over 1 minus cosine of x, or 1 plus. So the first thing I opted to do was to get a common denominator on the right side. So this fraction needs a 1 plus cosine. So it's 1 plus the cosine of x on the top, and 1 minus cosine of x, 1 plus cosine of x on the bottom. And the second fraction needs a 1 minus cosine of x. So I have 1 minus cosine of x on the top, and 1 minus cosine of x, 1 plus cosine of x on the bottom. The bottom is the difference of squares. When I multiply it all out, I'm going to end up with 1 minus cosine squared of x. 1 minus cosine squared of x is a Pythagorean identity. It's sine. So if I combine like terms on top, I have 2 plus 2, or 2 over cosine minus cosine is just going to be 1. And then 1 minus cosine squared on the bottom is the same as sine squared. 2 over sine squared can be rewritten as 2 times the cosecant squared x, which is what we were working for. Type D. Sine of x over 1 minus cosine of x minus cotangent of x equals cosecant of x. I need to work towards getting a common denominator, so I'm going to write the cotangent in terms of sine and cosine. Remember, cotangent is cosine over sine. And getting a common denominator, the first fraction needs a sine. And the second fraction needs a 1 minus cosine. So I have sine squared And I'll go ahead and distribute the cosine on the top. Sine squared x. Make sure you distribute the negative with the cosine. So negative cosine of x plus cosine squared x. If you rearrange the terms, you can end up with cosine squared plus sine squared, which is 1. So I have 1 minus cosine of x over sine of x, 1 minus cosine of x. Remember, when you have a rational, as long as you have the same thing on the top and on the bottom, you can reduce it or cancel it out. The 1 minus cosine of x will cancel with 1 minus cosine. I'm left with 1 over sine of x, which is the cosecant, which is what I was working towards. 5p. I have the cosecant of x minus the cotangent of x over secant of x minus 1 equals the cotangent of x. I don't see any identities right away, so the first thing I'm going to do is just change everything into sines and cosines and see if anything jumps out at me. On the top I have common denominators, but on the bottom I do not, so I'm going to get a common denominator on the bottom. 1 can be rewritten as cosine over cosine. On the top, when I combine the two fractions, I get 1 minus the cosine of x over the sine of x over 1 minus the cosine of x over the cosine of x. Whenever I'm dividing fractions, I put the second fraction or the bottom fraction. This is 1 minus the cosine of x over the sine of x times the cosine of x over 1 minus the cosine of x. And the 1 minus cosines will cancel. And I have the cosine of x over the sine of x, which can reduce to be the cotangent of x, which is what I was trying to get to.